Hello, everyone.
Hi. No way.
My name is Matthew. I'm going to be just basically handling the question side of things. Kaveh is our intern and a doctoral candidate who has made some amazing advances on tracing and injecting them into PyTorch.
Okay.
Please, floor is yours.
Okay, let me just share my screen. That's great. Let's come back here and start presentation. Okay. Hi, everyone. I'm Kaveh. I'm a machine learning intern at Ericsson, and today I'm going to present my latest work on using machine learning techniques on trace analysis called TMLL Trace Server Machine Learning Library. So I first give some introduction, but I'm hoping that everyone knows what is trace compass. But what is trace compass basically? So it's like an application for analyzing the performance and reliability by very simple thing. It receives some trace and logs and then gives some views, graphs, and metrics. But what is a trace? I mentioned trace compass. What is a trace? So trace is like a sequences of actions that happens inside the system. So if I want to like say basically the structure is something like this, it can have some fields and values. And as an example, we can see that, for instance, if in our system we send like a dir command, what happens actually inside the system? We can see first it goes to the main function, then goes to the another one. We can see which thread or which PID we are and at which timestamp. So if we can visualize it, we can see a very good like flame chart or flame graph based on our needs, and we can analyze the entire actions inside the system much more efficient and much more accurate. What is trace server? Like in my presentation title, I have pointed out like a name trace server. So basically it's something like comes from the core of trace compass. The main difference is that we don't have any UI components. So basically it's only the logic and the backends. It receives against the logs and traces and gives you some information, but in like the plain data. So we can apply our own analysis, either using the machine learning in our own application that has been built on Theia or any other stuffs. So what trace server can provide? Just as trace compass, it can provide many things like CPU and thread performance, like the disk performance. Like I have a thread, I have a trace, I imported a trace server, and then it will give me memory usage. It will give me functional call analysis and many more things that I couldn't just put them everything in this slide, but they are super cool. So what areas can be investigated with trace server? Yes, I have like those single and individual components. I can like merge them, like for identifying the performance bottlenecks. I can merge the CPU usage, disk, memory, and other things, and analyzing them, having like a comprehensive analysis on the top of them. I can find performance bottlenecks. Or for like optimizing the memory usage, I can use the memory usage, memory latency, and some other things, maybe some other things. Then I can have like a conclusion that, okay, I can optimize my memory usage through this. But what is the procedure right now? Consider that I'm a user and I have my trace. What should I do? I should like use a wrapper to like communicate with the trace server. I can use either Python or TypeScript right now. So I have my trace. I give it to the wrapper. It goes back to the trace server and then comes back until me. And then from this point, I have to apply my own manual investigations. But there are two types of downsides. The first one is like from the trace server. How should I get the data? Like the trace server, because not everyone knows the API documentation, and how should I communicate with the trace server? And also, what should I get? Like I want to find the anomalies. Should I get the CPU? Should I get the memory? Should I get both of them? On the other side, which is more specialized for the artificial intelligence and machine learning, if I want to apply like a normal clustering, what should I apply from the trace server? What type of analysis from the machine learning should I apply? Should I use k-means? Should I use dbScan? Should I use like a more sophisticated thing? Should I use easier ones? How should I apply it? Like if I want to use the k-means, like what is the procedure? Because maybe I'm a user, I'm an expert in tracing, but I really don't have that much information on machine learning. And finally, how should I analyze it? Okay, my machine learning algorithm has done this. How should I interpret that? What I really can do with that? So what we are proposing is that we add like a middleware layer called the TMLL between the user and the wrapper. So I'm a user, I import my traces into TMLL. It applies its own data pre-processing, give it to the trace server, comes back, apply its own techniques on the machine learning. It can be anything. I will show some primitive results afterwards. And then it can give some interpretations, visualizations, values to me as a user. And this is like the overview. I have my program. I trace it, then I have like a trace data. I give it to TMLL. It does many actions. And then it can give me some different outputs, like the anomaly detection, like the predictive maintenance, and other stuffs. What expected features, like which modules are we expecting from TMLL? So currently we've been working on the anomaly detection, like we have different type of analysis from a trace. And then for instance, we want to find between which timestamps, like there is a issue in the system. So we have been implemented many things, like from the very straightforward things like the z-score, like the interquartile range, into like a moving average, until a bit more sophisticated, like the random, like the isolation forest, finding the anomalies using the seasonality analysis, like for the periodic tasks that are just happening inside the system, but suddenly some things happen. We are trying to like find the anomalies through that. There are many other modules, but we haven't like been able to complete them because we are doing step by step. So as you can see, for the predictive maintenance, we can build performance model as of the system to like see if like based on the historical data, something is weird happening inside the system. We can apply some optimization modules, and also for the performance trend analysis, like since the beginning until now, can you give me side insights? What is the correlation between the components of the system and to the end? So for instance, I have put some examples for you to see like how it works. So basically consider that I have a trace, and inside that trace, I can get the CPU usage, the disk view, and also the histogram. I say histogram, you hear number of events. Like at this timestamp, this number of events has happened inside the system. Like individually, we might not be able to find some weird points because there are two things. The first one is that we really don't know the aggregation, like how it works. And the second one, we really can't differentiate between like an actual anomaly and like a simple noise in the system, because they shouldn't be considered as same, because then the number of false positives will go up. So consider that we can aggregate them together, like the both CPU memory and the CPU disk and the histogram. And then using like an isolation forest, we can see that the potential anomaly periods can be like these two time steps from this start to the end. I'm saying potential because because we don't have access to the context and the semantic information of the traces. We say statistically, these two timestamps can be an anomaly. Something weird is happening inside the system that doesn't match the rest pattern of the trace data. So the user can go and investigate and see if there's actually happening inside the system. Because if I like go back, so we have like three questions that Matthew has always told me. The first one is that, is there a problem? Because if there is no problem, we don't need tracing. And then where is the problem? So we are trying to propose some insights for the user to say, hey, instead of going and checking everywhere manually, this was like this and then and then and then, here are some highlighted points that you can start by investigating them, and hopefully there is something happening inside the system there. For the seasonality analysis, I've told some periodic tasks. For instance, I have like a duration of a function in my system, and we can plot that by the minute throughout the day. So if we can see there is a slight trend, there is a slight pattern that goes up and down and up and down, we can import the trace, and like these flames can be like these charts can be provided to the user. And also we can provide like a heat map for the user that say, hey, like at 1 p.m., nothing really happens in the system. But as we come closer to the afternoon and evening, like at 6 p.m. and 2 p.m., like the duration of the function has go much higher. So maybe at these times, something is happening inside the system. So we can see at like after 5:30 until the very beginning of 6, it seems that the usage of the system is a bit higher. So it's not matching the previous pattern. So we should be careful about that. Or we can also find the anomalies, like applying some analysis, like, and then finding the rolling mean. We can see that, okay, some points are much higher, like out outer of the normal pattern. I have pointed them with the green dots. So these points can be investigated by the user. We assuming that something is not following the seasonality pattern at those timestamps. And finally, for the correlation analysis, I have a trace and I want to know that at this timestamp, what is the correlation between like a disk and CPU or disk and the like number of events. So I can provide like here, the disk and the CPU have a very high correlation in the same direction. And then we can say, okay, give me like the comparison timestamps all together. Or we can say that, no, only give me between these two timestamps. So as you can see in these two timestamps, very specifically, like the disk and the histogram has like a higher correlation, but the CPU and disk has like decrease in the correlation that they have. And how we can actually use it in Theia? Very basic. We import the library, import our traces, and say, okay, I want these inputs and give me like an anomaly detection. We can put our own parameters, but most like 99% of the things are automatically done. So it was my presentation. I hope that you have enjoyed it. I'm glad to hear any questions that you might have. Thank you.
Thank you so much for that excellent presentation. It was very well presented and very quickly done in less than, well, just over 10 minutes. I'm very impressed. So I don't see any other questions, but I do encourage anybody at any point in time throughout any of our presentations today to take some time to ask the questions. Actually, there's one that just came in. Is trace server TMLL scalable to analyze or display really trace data like terabytes or trace data?
Yes. Now, the trace server is absolutely optimized to display huge amounts of data. Now, there are some concessions. You can make a request for all the data over the trace server, and the trace server is not very smart in that respect, and you will get a multi-gigabyte size bit of data. But that normally won't happen. What happens is that we give you the opportunity to use a sliding window algorithm to not do that. And another item is that you can have the trace server that is giving you the result of some analyses. Now, the beauty of analyses is that you'll take thousands of events and reduce it to tens of states. So we have a natural reduction, and this will reduce the load on your PyTorch and your machine learning systems.
Awesome. Well, thank you both so much again.